In this class, we want to look at introduction to plasma physics. Learning outcome. In this video, you will learn the following. History of the term plasma. We shall look at what plasma is all about. Analogy of plasma formation. Plasma state and quasi-neutrality. Shall look at what plasma physics is all about. Examples of plasma, mean free path and cross section. Shall compare the first state of matter. We shall look at Debye shading and Debye length. And lastly, application of plasma in industry. Let's look at the first one. History of the term plasma. The term plasma was first used in the mid-90s by a Czech physiologist called Quasineutrality. He was the first to use the word plasma, and plasma is a Greek word meaning formed or molded. He did an experiment and he came up. He used blood, that plasma is the clear fluid from the remain of a corpuscular material in the blood sample. When you get a blood sample, you put it in a test tube, in a centrifuge, you spin it. The various components that formed the blood sample will be separated into each component. The fluid that contains the fluid medium that contains the corpuscular material is what Quasineutrality called plasma. In 1922, a scientist called Debye, he looked at plasma, looked at the composition of plasma consisting of ions, electrons, and neutral atom. And according to him, that the ions, the electron, and the neutral atoms, they are like corpuscular material that are enstrained in a fluid medium. The fluid medium he called plasma. So this is a brief history of how plasma comes about. It was first of all used in medical line to represent the fluid that contain the corpuscular materials in blood. But thereafter, even looking at the composition of a plasma, the ions, the electron, and the neutral after ionization of atom, he came up that the ions, the electron, and the neutral, they are like a corpuscular material he observed in the blood sample that are suspended in a clear fluid. So this is just the brief history of plasma. Let's look at what plasma is all about. To explain plasma, let me use an analogy that an author used. And this is the analogy that an organizer of an event called people to come around, and when people came, invited several dancers, and he called the dancer to the dancing floor, and music was played. And on the dancing floor, people that came out, the dancer, they were close together. The music was ongoing, and as the tempo of the music increases, the dancers started spacing themselves so as to enjoy the music. The tempo of the music was increased the more, and the spacing continued. From there, when the music was so intense that everybody started enjoying it, all the dancers were separated and the music continued. So the organizer of the event here is a scientist or a physicist. The music here represents heat. And the dancers that were close together represent the solid state of matter. And as we all know, the solid state of matter, the molecules, they are close to each other. But when heat is being applied, the tempo of the music increases. When solid is heated to a very high temperature, the molecule, the crystal lattice breaks, and the molecule will now, the solid will melt into a liquid. So as the tempo of the music increases, the dancer space. So that gives us the second state of matter called the liquid. And as the music increases, the heat, music here represents the heat, you discover that the liquid will reach its boiling point, will vaporize. And that gives us the third state of matter called the gas. And when gas is being heated, it changes to the fourth state, which is what we are looking at, plasma. And at this point, like in the case of the dancer, each person is spaced out, enjoying the music. So there is dissociation here into ions and electrons. So this fourth state of matter, which we call plasma, is gotten when a gas, a state of matter, is being heated to a very high temperature, ionizing the molecule of the gas into ions and electrons. So plasma is the fourth state of matter. So with this analogy, we can understand the various transitions from solid to liquid, liquid to gas, and gas finally to plasma. So plasma is the fourth state of matter. So we can say that plasma is an ionized gas in which all or a large number of atoms have lost one or several electrons and exists in a mixture of free electron and positive ion. Or we can say plasma is a quasi-neutral system of a large number of charged particles which exhibit collective behavior. So that is the definition of plasma, and this explains the transition of plasma from the solid state to liquid state, from there to gaseous state, and finally to what? The last state of the last phase of matter, which we call plasma. So when you heat gas to a very high temperature, the molecule ionizes, giving us electron and ion. That is what our plasma. Okay, let's look at, we have looked at plasma and also the analogy. Let's look at plasma state. What do we mean when we say plasma state? Plasma state. It is an electrically conducting medium. Plasma state is an electrically conducting medium, and the medium contains electron and positively charged ion, and can also contain neutral atom or molecule as well. So when we talk of plasma, what comes to mind is electron. What comes to mind is ion, electron, and also neutral atom. So plasma consists of ions, electrons, and neutral atom. And because of this, we normally refer to plasma as a quasi-neutral system. What do we mean by that? In plasma, we have that the number of ions is almost equal to the number of electrons, with the presence of some neutral atom. And because the number of ion and electron are almost the same, we call it a quasi-neutral system. For instance, if you have an electron, let's say 100 in the system, if you have an ion, let's say 101, you discover that they are almost the same. Because of the variation in this difference, we say that what? They are what? Is a quasi-neutral. So plasma is a quasi-neutral system. And what do we mean by this quasi-neutrality? Quasi-neutrality means almost neutral, like the instance given here, the number of ion and electron, they are almost cancelling out. And in the system, if the ions and electron, they are the same, the ions positively charged and the electron negatively charged, you discover that for a system like this, ion 100, electron 101, discover that the system is almost neutral. And because of that, we normally refer a plasma to be a quasi-neutral system. And because of that, we normally say quasi-neutrality. And what we mean by that is that the number of electron and proton, they are almost the same. So a plasma is almost neutral. So that is what we mean when we say a plasma is a quasi-neutral system. Okay, let's look at examples of plasma. Example of plasma. Let's look at it briefly. Examples of plasma. Haven't known what plasma is, haven't known plasma state, we want to look at examples of plasma. And under the example here, we can classify, we can look at it in three-fold. The first one is non-fusion terrestrial plasma. Non-fusion terrestrial plasma. And here, example of non-fusion terrestrial plasma, we talk of the example, we have arc, we have neon sign, plasma in this system, we refer to them as non-fusion terrestrial plasma. We have fluorescent lamp, we have wedding arc, and we have lighting. All these are example lightning. All these are example of non-fusion terrestrial plasma. Other example of terrestrial plasma, we have looked at the first one. The second one is fusion graded terrestrial plasma. Fusion grade terrestrial plasma. And here we talked about things like Tokamak, how plasma is produced using a fusion reaction. Here we talked about Tokamak, plasma has been produced using Tokamak. Here we talked about stellarator. It's another example of non-grade terrestrial plasma. Stellarator. Then we also have reverse field pinch. Reversed field pinch. These are example reverse field pinches. These are example of fusion grade terrestrial plasma. And the third one, which is the last example of plasma, is space plasma. And here we talked about plasma in space, plasma in interstellar space, plasma in a solar atmosphere. Solar atmosphere. So these are the three examples of plasma that we have. We talked about the non-fusion terrestrial plasma, we have the fusion grade terrestrial plasma, and we have the space plasma. And like I said, in the space plasma, we talked about the interstellar space. Here we have plasma. This is a natural one. We have the solar atmosphere. Plasma is found in the solar atmosphere. So the last one, the space plasma, is a natural one, while the fusion grade terrestrial plasma using Tokamak, stellar, and reverse field pinch is a plasma that we produce in industry, in laboratory. And even the first one, they are all ways that we produce plasma in using artificial means. This one is a natural one. Plasma is found in space. Okay, let us look at Debye shading and Debye length. Debye shading and Debye length is the next thing we want to look at. And to understand it, Debye shading and Debye length. To understand this, let us look at Coulomb's law. Coulomb's law. Let's look at Coulomb's law. According to Coulomb's law, that the force of attraction between two charges is directly proportional to the product of the charge and inversely proportional to the square of the distance between them. So let me explain this way, that if we have two charges, Q1, Q2, at a distance R, according to Coulomb's law, that there is a force of attraction between Q1 and Q2 if they are of opposite charge, like positive, negative, or repulsion if they are like charges. So according to Coulomb's law, that irrespective of the distance, that the force of attraction can be experienced. But in plasma, we have earlier said that plasma is made up of ions and electrons. So for instance, if you have an ion in a given point, this very ion will attract electron. And by attracting this electron, the electrons will now form a crowd, thereby reducing the force of attraction to every other nearby electron. So the distance observed is what we call the Debye length. Then the shielding, that this electron shield other one, we call it the Debye shielding. So the difference between Coulomb's law in terms of charges and Coulomb's law considering plasma is that in the case of Coulomb's law for two charges, the force of attraction, it is indefinite, meaning the force of attraction can be experienced irrespective of the distance, but however the force is much if the two charges are close to each other, because it's a function of distance. But in the case of plasma, the force of attraction is definite. What do we mean by that? As an electron is attracted to the ion, the electron form a cloud, form a shield, thereby reducing that force of attraction to other nearby electrons. And that shield is what we call the Debye shield. It was named after the scientist Debye that discovered this. So what do we mean by Debye shield and Debye length? Debye length or Debye radius is the distance to which the force of attraction between ion and electron exists. The distance to which the force of attraction between ions and electrons extends. While the Debye shielding is the cloud of electrons formed by closest electron around positive ion due to Coulomb's law that shield other electrons from being attracted by the ion. So we have the Debye shielding and we have the Debye length. I believe it's straightforward. The difference, like I said earlier, from the Coulomb's law for charges as we observe in other areas, is that the force of attraction is indefinite, can be extended to any distance. However, the closer the charges are, the greater the force of attraction observed. But in the case of plasma, which we have earlier said that it's composed of ion and electron, the attraction, the moment an ion is attracted to an electron, the electron will now form a shield. And that shield reduces that force of attraction to be definite, unlike the case of what? Coulomb's law for other charges. So the next thing we want to look at is application of plasma in industry. Plasma is very, very important, is very, very useful in industry. So we want to look at it, application of plasma in industry. And I want to let us know that we have earlier said that plasma is the fourth state of matter, and it has, because of its high temperature, because of the energetic electron that plasma is composed of, energetic electrons and ion, and also because plasma exists in a wide range of density, pressure, and temperature. Because of all these characteristics of plasma, it has several practical industrial applications. Let's look at it one after the other. The first one we want to look at is the application of plasma in semiconductor. Application of plasma in semiconductor. Semiconductor electronic is the first one we want to look at. As we all know, semiconductor, there are materials between conductor and insulator. However, a semiconductor can through a process called doping, whereby impurity is inserted into it and it becomes a good conductor. So, plasma has been applied in semiconductor electronics. For instance, we have what we call plasma etching process. Plasma etching processing, for microelectronics, it has become important techniques for producing very tiny semiconductor device. Before now, we make use of a wet process, the chemical process in our etching, but through the use of a plasma, now we talk about the dry process. And the dry process here, using plasma, it is faster, very fast. It is more accurate when you are doing the etching, more accurate, and it can be done in a desired direction. Are we seeing the desired direction? Are we seeing the advantage of using plasma in plasma etching process? Like I said before now, chemical has been used through the wet process, but with the use of plasma etching process, semiconductor electronic devices, the microchips has been produced. And this day, talk about microchips, talk about the nanoparticle is the order of the day, whereby a component that's ordinarily supposed to be large has been reduced through the use of a microchip. So we use a plasma etching process in the semiconductor electronics, and it is far, far better than the wet process that we used before now, use it through the use of chemical. In the case of plasma, we talk about the drying process, and like I said, the process is very fast, more accurate, and you get the desired direction that you want. So one of the application of plasma in industry is in the semiconductor industry. Let's look at the other one. The other one, we have the plasma spray. This number one. Plasma spray. It's another application of plasma in industry. So plasma spraying is used to apply a thick coating to substance that do not yield to other treatment. We use the plasma spray to apply a coating to a substance. Before now, several processes has been used, but it has been found that plasma spray give a better result. And this coating, even down to automobile, the car is being sprayed using a plasma spray, and a good result has been gotten as compared to other process that has been used before now. Then we also have other ones like plasma welding. This is the third one. Plasma welding, plasma cutting, and material processing. These are areas where we use our plasma in industry, in welding of metal, cutting of metal, and also material processing that involve metal. Plasma has been used, and the result is far better than other methods that has been used before now. We also have a plasma display panel. Plasma display panel. Plasma display panel is another area where we talked about application of plasma. This day, the use of a plasma television is the order of the day. Before now, we use our cathode ray, the tube, in our television, and we all know the size and the weight. But through the use of plasma display panel, there is great improvement in our industry electronics. We have better plasma television now of different shape and sizes through the use of plasma display panel. We also have plasma and the use of plasma also find application in the treatment of waste. In the treatment of waste. Before now, various methods that has been used in the treatment of waste. The use of plasma has proven to be far, far better. Here, the waste, you apply the plasma to the waste, and in the process, the hazardous waste, the high temperature from the plasma, the ions, will reduce the hazardous waste. And waste treatment, plasma has been used in waste treatment. Also, in plasma lighting is another application. And here we talked about the use of fluorescent lamp, plasma lighting is the other application of plasma. We have different, before now, we make use of different lighting system, talk about the use of lamp, the kerosene, but with the use of, with the introduction of plasma, we have fluorescent lamp that give us better light. We also have mercury lamp, and this has been applied, the fluorescent lamp, the mercury lamp has been applied in various places, concert hall, We have different light being displayed even down to supermarket. So plasma has been applied also in our lighting system. So the use of plasma is the application of plasma. In fact, it is almost in all sectors. So the use of plasma in industry cannot be overemphasized. So plasma is very, very important, and it finds its application in almost all sectors. There are other ones that we may not mention here, but all we are trying to say here is that the application of plasma in industry, like we mentioned, semiconductor electronics, there is great improvement in the electronic industry as a result of application of plasma, plasma spray, coating of materials, even down to automobile industry, the use of plasma spray, plasma welding, cutting and material processing. We also have application of plasma there. Then plasma display panel. This day, the cathode ray television is going into extinction this day because of the introduction of a plasma display panel. We also have treatment of waste. Plasma also have its application there. Then, as earlier mentioned, in the lighting system, different lighting system, the fluorescent, the mercury lamp, all of them, they are the order of the day now as a result of what? Application of plasma. So plasma is very good, and the application is everywhere. Thank you very much for listening. Please subscribe to my channel for more videos, and also like and share this video. Bye for now.